Okay. Last time we started with the first lecture, which is from chapter 5 and 6, and we are focusing on this outcome of the course, where you learn about the basic concepts of traffic engineering. We talked about what is a traffic stream, why it keeps on changing, the normal changes, the routine changes. What are the traffic flow facilities we have? We have two types, interrupted and uninterrupted, and the main difference between them is the intersections. And then we moved on to the discussion of traffic flow parameters. Again, they are divided into two types, macroscopic, microscopic. Macroscopic, you are looking at the entire traffic stream. Microscopic, you are looking at each vehicle maybe, okay? And these are the three under each category. And we started with the first macroscopic parameter, which is volume. And we define volume as vehicles per unit time, okay? Based upon the unit of time, we can call the same thing as volume, flow, or rate of flow, okay? But all of them are vehicles per unit time, okay? So if you have unit of time of 1 hour or more, volume. If you have less than 1 hour, flow. And how do we get the flow rate? Per hour, yes. Okay, and then daily volumes are used for planning purposes. If you are planning a highway, a bridge in future, then you need daily volume, and it basically gives you the total demand of the highway, irrespective of whether people are coming or going, or they are using in the morning or in the evening. It's not detailed, just one number for the whole day, okay? And that can be averaged for the whole year, including all days, AADT. It can be done for the whole year, including only weekdays, AAWT. It can be done for all days less than 1 year, ADT, and all days less than 1 year, only weekdays. That will be AWT. We looked at this example where you can calculate the total for the whole year, because you have total volume, okay, all days, total volume, weekdays, you know the number of weekdays, you know the total number of days, and then you can calculate the ADT and AWT for each month as well, okay? But AWT and ADT can be for anything less than 1 year, anything less than 1 year. So here the data is 1 month, the minimum unit is 1 month, so monthly. It can be weekly as well, and later on you will see some other ways of taking ADT. Okay, then we talked about hourly volume. Hourly volume is used for design, okay? But you are doing the design for future, and for future you have the total demand. So you have to convert that total demand into the design hourly volume you need. So we need the factors, factor for peak direction, factor for peak hour, okay? And these factors should be taken locally. You have to go to the field and collect some data on existing highways, similar highways, to get this, get these values. And I showed you this table, which gives you a range of these values, and we tried to apply them in this example, and we saw that there was a big change. When you go from minimum to maximum, there's a big change, okay? And you cannot allow that much change in your design, that you cannot allow that much variation in your design, okay? So that's why the key point was these factors should be local, okay? And they should be from the type of highway you are trying to design, okay? Because even here you can see it's not the same range for all highways in all areas, okay? So if somebody goes and says, I will build a new bridge on Sheikh Salman Highway, he cannot take the factors which are calculated using a local street data. They will not match. Okay. So daily volume for planning, hourly volume for design. Then what is the role of flow? Why do we go into the hour and look at different intervals of the hour? How many vehicles in, for example, 15 minutes? Why do we need to do this if my design is complete with hourly volume. And this is the example in which we saw the effect if you do not consider the flow. And I gave the example of a structure. Okay, so your total load can be same, but instead of point load, you assumed it to be equally distributed. Your building will fail not because you did not consider the load. Your building will fail because you did not consider the point of the load. Okay? Same thing happens with traffic flow as well. If you do not consider the variation in time, your highway will fail. It will have congestion. And we looked at this example. Okay? So if you go with equal variation, you start to have your queue after half an hour, and this queue will continue even after the hour. It has not become zero. Although the total is same. Total of this and total of this is same. Only the distribution is different. Okay? So we need to include one more factor in our design to accommodate for the fluctuation of flow, to accommodate for the change in flow. Okay, the distribution. Yes.
Can we design for the maximum?
Yes, we do. Okay. But we include that maximum as in the by way of factor, because now imagine you are designing a highway which is not there. So this I showed you this example to show you the effect of the flow, but the actual problem is not this. You get my point? Here you can see, okay, which one is maximum? This one, right? So I convert this into flow rate and I have my value for design. But who will give me this value? There is no highway. I cannot go at 4:30 and 5:30 and 5:45 and look at, there is nothing. You are going to design it, right? So this value does not exist. So I need a factor to put with my design volume to accommodate this 1200. Got it? And that factor is called as what? What is that factor? PHF. Okay. Okay. Peak hour factor. So this is why we need peak hour factor. So peak hour factor is used with the design volume as well. So now we have three factors for the design volume. Okay. Three factors are required to calculate the actual design volume. Which ones are those factors? Which factors?
Peak direction.
For the peak direction?
Peak hour.
For the peak hour? And PHF. Okay. So for two factors, you rely on the observation, even this one as well. So how do we calculate peak hour factor? You take the total hourly volume of your highway divided by peak flow rate. Okay. So if you go to this example, your total hourly volume was how much? How much was it? How much is the total here for 1 hour? Total 4,200. Okay, divide by peak flow rate, and as you said, flow rate, you have to convert the flow into rate, right? Rate of 1 hour. Okay, my peak flow rate is this one. My peak flow is this one. So I will convert this into 1 hour. Okay. Okay, so this will give me the peak hour factor. Clear? Okay. Any questions? Clear? So one is the total of the 1 hour. The denominator is just the value of peak flow is converted to per hour. Okay? Any questions?
What is 4 hours? 4.
What is 4? Very important question. 4 is because it is 15 minutes. Okay? So I'm trying to convert 15 minutes to 1 hour. Okay? Clear? If somebody doesn't do this, but they do this, Is that right or wrong? Same, right? Okay. What is the point here? To convert it to per hour. Multiply by 4, divide by 15, multiply by 60, or whatever weird way suits you. But make sure I understand it. And I'm dumb. Okay, so I don't understand many of the things. Okay. So yes, you are all A graders, but you will get inshallah C and D because I will not understand your answers. So be ready for that. Okay. And you cannot change me, obviously. I'm old. So you have to change yourselves. So once you have your grades, you get C and D and okay, just curse me and move ahead. Okay. Now, what was the definition of flow? What was the definition of flow? Flow. Like there's volume and flow and rate of flow, right? What was? Less than 1 hour, right? Yes. Is 15 minutes the only thing I can have less than 1 hour? No. Okay. So this will not always be multiplied by 4. Okay. So thank you for the question. So this will not always be like this. Clear? So you have to look at the time of the flow. Okay. He remembers the whole course more than me. Leave him. You don't understand anything, ask him. He will tell you in Arabic. Better than me. Seriously. So which version are we doing? Am I what? 5? 6? Okay. He is going one step ahead of Tom Cruise. Okay. You were there in the meeting, right? They were saying you can take 2 courses with the clash of the final exam. Okay. The peak hour factor has a range. Okay. Now, these factors, values, whatever. You need to have an idea what these values are. Okay. This will give you a very good chance of checking your errors in the exam and also in your life. Okay, there's a rule which they call as garbage in, garbage out. Okay, so if I put, for example, I mentioned maybe last time. So I missed a 0 here. So I did 420 upon something. Still get an answer, right? I'll get an answer. Okay, but the answer will be very, very low. You get my point? Okay, instead of 0.8, it can be 0.0 something. Okay, if you know what you are calculating, what is the range, then you know your answer is wrong, and you will check it. Okay, but if you don't know what you are doing, you just write it and go ahead. Okay, and I already told you about myself. So if you don't know, I don't know what you did. Okay, so you have to keep these things in mind. So peak hour factor has a range 1 to 0.25. Okay, 1 means equal distribution. 1 means equal distribution. Okay, but equal means what? This and this should be equal, right? Yes. Okay, so your hourly volume is same as your peak flow rate. So whatever was happening in the whole hour, the peak 15 minutes are showing the same thing. So if I took the 15-minute value and distributed for the whole hour, it will get me the same answer. So this upon this will give me the same, like it will give me 1, right? So this is why we have 1. Okay, and 0.25 means what? So this is the now again 0.25 is if you are taking 15 minutes interval, which we normally do. Okay, so this minimum value is because we are taking 15 minutes interval. Okay, so how do we get 0.25 here? 0.25 means 1 upon 4. So what will become equal? Okay, I will only be left with 1 and 4, right? So V and V15 are equal.
How is that 15?
Okay, so this is now point load. Okay, the first case was, one is when you have equal distribution loading, okay, of traffic, and this one when you have point load. So all traffic in 15 minutes, rest empty. Okay, so 15 minutes became equal to 1 hour, not flow rate. 15 minutes flow became equal to 1 hour. Got my point? Okay, and the same rule applies to change in peak hour factor. So one was what? Equal distribution, right? So when the traffic is equally distributed, you will get 1 or close to 1. So if the peak hour factor is increasing, that means the distribution of traffic is becoming equal. Got it? Okay, and vice versa. If it is reducing, the traffic variation is increasing. The distribution is getting more and more on one instant. Clear? Okay. And I mentioned this in the last lecture as well. Urban areas have equal distribution because they have more traffic. Okay, and rural areas have more concentration of traffic in one particular time. Okay, so that's why for urban areas you can see the factor is close to 1. For rural areas the factor is less than 1. Okay, 0.25 is a very extreme value. You don't get it every time. Another macroscopic factor is speed. Now throughout the course, throughout the book, you will see that speed is always discussed with travel time. Speed is always discussed with travel time. Okay, because they are interrelated. Okay, they are interrelated. If speed increases, time decreases. Okay, right? And obviously you can calculate speed using distance upon time as well. And when we say travel time is not taken for a small section. We don't take travel time for a small part of the route. That will have too much variation. Okay, so travel time is normally taken for the entire segment. So some of you are now taking, selecting the routes, the parts for your term projects. So the whole part will be taken for travel time. Speed you can take any 50 meters, no problem. But if I ask you for travel time observations, which I am not doing now, maybe inshallah next semester, that will be, so don't repeat the course. Okay, so the travel time will be for the entire segment. Clear? Okay, so this is like the normal rule that we follow. The speed can be for the whole segment, for a small part of, for even a point as well, but travel time is not that. So if you tell me I recorded travel time of vehicles which were passing in these 20 meters, we will discard these observations. We will cancel them. We will not consider them for travel time. For speed, yes, we can consider it. Travel time, no. Clear? Okay. When we were discussing macroscopic and microscopic and the difference between them, speed was in both of them. Speed was macroscopic, speed was microscopic. Okay. Now we are discussing macroscopic now. Okay. So which speed are we talking about? The whole group of vehicles. Okay. Obviously the whole group of vehicles will not have the same speed. So we have to take average or mean. Okay. The statisticians say that these are two different things. So normally we don't interchange between them. So when we say space mean speed, we mean mean speed. We cannot, somebody cannot come and say, okay, I will say it space average speed. Okay, they get angry and they make bombs and blow everything up. The statisticians do this. Okay. So space mean speed and time mean speed. You can take, like I told you, for volume, daily volume, right? There were different methods of taking the average for the whole year, for less than 1 year, for all days, for only weekdays. Okay. Similarly, for taking mean of speed, there are different methods. Okay, two different methods. You can take, one of them is called time mean speed, the other one is called space mean speed. Time mean speed, space mean speed. More relevant to traffic engineering is this one. Okay, more relevant is this one. So in most of the cases in this course, you will be looking at this one. Okay, but this one is also important. Okay, there's a very important thing which you need for your term project, which will come from here, for which you will do the time in speed in the second submission. So what is the difference between them? Time in speed is the speed of vehicles when they pass over a point or a lane. Okay, so as they are passing, I am trying to find out their speed, and then I take their mean. That will be called as time in speed. Clear? Okay. Space mean speed is what speed on average they are maintaining over the whole segment. Okay, space mean speed is when they are over the entire section. So from point A to point B, the whole thing. Okay, so this mean speed is over the entire section, and this mean speed can be over a point or a small part of the road. Clear? Okay. So which one will need travel time? I told you about travel time. Which one can be calculated using travel time?
Space means speed.
Space means speed. Okay, because we said travel time, we take it for the entire section. Okay, but obviously we you will see throughout this course that when we say this thing should be ideally taken from here, but the real world is not ideal. Okay, so we have to look at some other method of calculating space mean speed as well. Okay, so this is what you will see now. So the first equation is for time mean speed, the second equation is for space mean speed. Okay, time mean speed. Now distance upon time equals what? Speed of velocity, right? So you can replace in the first equation, you can replace d upon t with speed. Okay, the first equation does not have to be d upon t, summation of d upon t. You can do directly summation of speed, summation of velocity. Okay, the equation is still valid. Okay, so if you are using a speed gun, you have a radar, okay, or you have some device which can give you the speed directly, then you will use that speed. Okay, you will not do distance upon time. But if you are without that device, you don't have any means to observe or get the value of speed directly, then obviously you are only left with the other option, which is to do distance upon time. Okay, so the equation is showing you the general term. Okay, but the if you have the device, you can do distance upon time as well. N is number of vehicles which you have observed for the speed. Clear? Okay. In the second case, we have the distance, and then we are doing now summation of t upon n becomes what? In the second equation, the denominator can be called as what? What can I call this whole thing? Summation upon number is some average, right?
Average of time.
Average of time. Okay, so distance upon average of time. Clear? Okay. Any problem? Okay. So for example, we have this example here. We have 6 vehicles. For all of them, the distance was 1000, and for these 1000 feet, we have taken the travel time. We have noted down the travel time. Okay, and we have to calculate the time mean speed and space mean speed using this data. Okay, so the first thing I can calculate very easily is space mean speed. Okay, what was space mean speed? You need the distance, okay, over average of time, right? Okay, so what is the average of time here? Tell me. Okay, so space mean speed is 1000 upon 19.3, which is
19.8.
Yes. So the speed is
51.8.
51. Sure. Okay. For space mean speed, we do distance upon time, and then we will do the summation, and then we'll divide by the numbers, right? So I need d upon t for each vehicle now. Okay, tell me. Yes, d upon t, each vehicle. First one, 50, 50, 50. Okay, and then the time in speed will be the summation of these values, okay, upon the number. Number is 6. You have 6 vehicles. So how much is that? Sure. Check this one.
The first one is 50.8.
The first, which one?
51.8. 50.8.
This is 50.5. And this one? Sorry? Now for TMS, we will do the summation of these
Over the number?
over the number.
The average time is 19.3 or 19.8.
19.8, as he said. But now we cannot trust him. Uh-huh.
But you're right, 19.3.
19.8, this one, I just corrected here. See, the same thing will happen in the exam. We'll come out and say, doctor made a mistake in the question. My answer was correct.
It's 50.5.
Okay. Clear? Huh? So what are we doing here? First of all, as I mentioned, that statisticians say that when you change the term, it has a little bit of effect on the value as well. So you can see we use the same values. We calculate the mean in the end, the mean of the speed, but we did a slight change in the equation, right? Here it was distance upon average of time. Here it was distance upon time and then the average. Okay, so and you have a small difference in the values. Okay, so they consider this difference as important as well. And you can see that which one is higher? TMS is higher. This is a normal trend. TMS is normally higher than SMS. TMS is normally higher than SMS. Here, it is just because of the equation. In this case, it's just because you change the equation. Okay? In real world, this difference is because when you take the instantaneous speed of the vehicle, you are not taking the entire section, because remember, you have to go back to the definition of SMS. SMS is over the entire section, and TMS can be over a point or a small distance. Okay, so in real world, when you focus on a particular point for a speed, okay, your answer is normally higher. Okay, because if you look at the entire section, no vehicle will go at the same speed, so it will at some time it will decelerate as well. Okay, so looking at the speed of the entire section will always be lower because there is deceleration involved here. When you go from point A to point B, you will decelerate. But if you are looking at one point, there is no deceleration rate here. There is no deceleration here. I am just looking at one value of speed. Clear? So TMS by definition is higher because there is no deceleration involved here. Clear? Okay. But in this question, it is mainly because of the change in the equation, because we are using the same data obviously. But if I tell two people, you do the observations for TMS and you do the observations for SMS for the same highway on the same day on the same time for the same vehicles. Okay, but they are doing it separately. So you will get a difference between them, and the difference would be this one will be higher, even if they are the same vehicles on the same day on the same time on the same road in the same direction. Clear? Okay. And the reason is for TMS the effect of deceleration is almost none, but for SMS it's the whole segment. Okay. There is only one special case in which both of them can be equal exactly, when the vehicles, so how many vehicles we are taking here? 6, right? If all these six vehicles, all of them go from point A to point B with the same speed, not same speed as each other. Like what was the speed at point A of vehicle 1, it remained the same till the last point for vehicle 1. Okay, so if it was 55.5 for vehicle 1 from point 0 to point end, okay, it was 55.5, no acceleration, no deceleration. And same thing for vehicle 2, if it was 50 at point 1 or point A, it remains 50 till point B, same, not going up and down and then reaching 50, no, 50 constant. Okay, so only in this case you have the scenario where both of them are exactly same, time and speed and space and speed are exactly same. Because what did I say about time and speed? We are not considering any variation, right? Time and speed, there is no variation. So if there is actually no variation, then both of them are same. Got it? Clear? So, but this is a very obviously very special case. Okay, the last macroscopic parameter is density. What is density? What is density? Mass per volume. Okay. Now, volume means space. Okay, and mass is the quantity of the material you have, right? So, in case of traffic, okay, how do we measure traffic? Number of vehicles. And space is the road, right? Okay. So density, traffic density is number of vehicles per unit space of the road, per unit length of the road. Okay. Number of vehicles per unit length of the road. Clear? And you can make it per lane as well, or you can make it combined. You have 3 lanes, number of vehicles in all 3 lanes in 1 unit length, or number of vehicles in 1 unit length in 1 lane. Okay, so density can be per lane or density can be total for all lanes. Okay, and your length can be kilometers or miles depending upon which unit system we are using. Wherein we use kilometers, right? Okay, the book is using miles. Now the problem with density is its measurement. If I ask you go to the highway and get me the density of vehicles, what you would do? How do you get the density? So for density you need what? Number of vehicles in 1 kilometer. Okay. Now you will do what? Go to the highway and count. Count for how long? 1 kilometer, right? Huh? Why? No? What's the problem?
One light kilometer.
Huh? Yeah, 1 line. Okay, 1 line. So you count, start counting from here and you go up to 1 kilometer. Huh? That time is a problem, right? You cannot, until unless you can do it instantly, this number is not constant. This number is not constant. From the start of your counting till the end of the counting, it's not constant. I started counting here, I reached after 1 kilometer. The count is not the same. Okay, when I started here, there were 3 vehicles here. Now there are only 2 vehicles. So it's not the same, right? Okay, so density must be taken instantaneously. You cannot start counting from 0 and go up to 1 kilometer or 1 mile. Okay, you have to, basically the term which they use is snapshot. You need a snapshot of the highway for the whole kilometer or for the whole mile. At this time, in this length, these are the vehicles. No change. Okay, so the density is taken at a particular point of time. Okay, you cannot waste time in counting vehicles because when you are counting, vehicles are moving. So density is changing. Clear? Okay. So what are the methods? Yeah, one of the methods which we will see in this course, and we will use it as well, is through calculations. Okay, to have density taken as instantaneously, we need some device, some equipment. Okay, and the only device equipment we have is our phone, right? Which is not enough. So we can rely on calculations. We can look for other parameters which you already studied. How many parameters we have studied? Tell me. I started with what? Volume and flow, flow rate, speed. So these things can be used to calculate density. They have an equation where these things are related to density. Okay, so this is one method. Then we can do it using devices as well. We'll talk about them when that topic comes. Okay, density, although very hard to observe, it is important for us because of the reason that it gives you the quality of flow on the highway. It tells you about the quality of flow on the highway directly. Okay. Now if you take flow or speed, so you may have a very high flow, but the quality of flow is still good on the highway because the highway has 5 lanes. Get the point? The highway has 5 lanes. So it can have 5,000 vehicles in 1 hour without any problem. Okay, but if those 5,000 vehicles are on a local street which has only 2 lanes, then there's a problem. So you cannot rely on flow. Same thing happens with the speed. Okay, you are driving inside the campus here, and speed is 50, 60 is more than enough. Okay, this is the speed which you are supposed to drive on these roads. But if you are driving outside the campus, 50, 60 is considered very slow, right? So the speed and flow can be deceiving. Okay, they can be confusing. You may take the same value, but it may not mean the same thing. But density does not have this problem. Okay, you can rely on density for almost all types of highways. Okay, and the same value can mean the same thing because it's depending upon the unit length. Okay, so density is directly related to the demand. Okay, when the demand is higher, there will be more vehicles on the road, right? When there are more vehicles and the unit length of the highway, the density will be higher. Okay, so if the density is higher, you can say the demand is higher. Okay, but this is true for the flow as well. Flow is higher, demand is higher, no problem. But the other two things are very interesting. The second thing is about the selection of speed of the drivers. Okay, so you are on the highway. Okay, you just crossed an intersection, you just crossed a signal. Now you will decide what would be your speed, right? And you decide on the basis of what? How do we decide?
How much traffic there is?
How much traffic there is?
Am I late or not?
Am I late or not? Always.
Intersections.
Huh?
The intersections.
The intersection, the other intersection.
Is there any other?
You're too honest. Yes. Okay. But even within the speed limit, doesn't mean that okay, the speed limit is 120. I will always go at 120, right? I have to look at the most common thing is the traffic. Okay. And within traffic, the most important thing is the vehicle in front of you, right? Okay. So if the distance between you and the other vehicle is less, your speed should be less, unless you have the other things. I'm getting late for the movie, and there are no radars, right? But normally it should be less, right? Now this is spacing. What is the relationship of this spacing with density? The spacing between you and the other car. What is the relationship between this and the density?
Less distance, more density.
Huh?
Less distance, more.
Less distance means more density. Vehicles are close to each other. There are more vehicles in the unit mile. Okay, there are more vehicles in the unit mile. So more density means you will have less spacing, and less spacing means your speed will be less. So your speed is less because of the density. Got it? Okay. And taking it further, your speed is less. It can be more. Okay. Maybe you may decide to increase it little bit. Okay, but it will be risky, right? Okay, so and for example, you have to change your lane. You will feel more comfortable if you have spacing around you, right? You have to have changed your lane, you have to make a turn and so on and so forth. Okay, you will be more comfortable if you have more space around you, right? Okay, so now density, and we said space is related to density, right? The space around you is related to density. Okay. So now density is affecting your behavior as well, how comfortable and how convenient you are on the highway. Get my point? Okay. So density is a measure of demand, but this is also common with the flow as well. But density affects the speed of the drivers, I mean their choice. They are choosing it, right? I'm not talking about if the signal is red, obviously then stop. I'm talking about your choice when you have the traffic and it's moving and so on. So you decide your speed on the basis of density, the space. Okay, and the same thing happens to your comfort level and convenience as well. Okay, more space, you may feel more convenient, more comfortable. Clear? Okay. Now you can see some of these things I can measure. I can measure speed, for example. I can measure demand. We discussed last time as well. We have equations to calculate demand even if there is no highway there for future, right? Okay. But some of the things which we cannot measure directly. Okay, like comfort, freedom, convenience, we cannot measure them, right? Are they important? Or no?
Yes,
People are
important.
thinking. Is comfort important? What if they make the class 6 o'clock in the morning? People who are thinking they are important, for God's sake. It's your life. Why are you thinking? Comfort is important, freedom is important, okay? And it's also important that you should not have too much freedom. Because then you start thinking, should I be comfortable or not? So yes, these things are important, but we cannot measure them. So density gives a indicator of these things, which we cannot usually measure. So these are the three microscopic parameters. calculation of density, we will look at it later on. Okay, but for the time being, keep it in mind, you can measure it using a device, you can calculate it using other parameters, and you look at the calculation. Some of them will come in these slides as well. Okay, we already talked about spacing, right? We already talked about spacing. There is a spacing when you go and you are driving your car, you go for the test. Okay, so the instructor is beside you, he is busy on the phone. They are always like this, right? No? Who did you go? He was not busy on the phone. Maybe it was before the phone got invented. He is very old. I call him Tom Cruise for what reason? How old is Tom Cruise?
I'm 21.
And you are Tom Cruise? I'm asking about Tom Cruise.
Tom Cruise?
He doesn't know. Get out. Okay.
Sign me as a friend, okay?
Huh?
Attend me, I will leave.
Okay. The problem is he can leave and he will still pass. So stay. Going back to the point, when you are learning how to drive and the instructor, he will always tell you keep some spacing, right? Okay, keep some spacing between you and the other car. Okay. So that spacing is the clearance between two cars. What he is talking about, or she is talking about, is the clearance between the two vehicles. Okay, which is also important, obviously. But when we are doing traffic flow analysis, this clearance is not enough for me. Okay, to have the value of clearance is not enough for me. My spacing should include the length of the car as well. The spacing we need for traffic flow analysis should include the length of the vehicle, car, truck, bus, whatever. But that should be part of it. Okay, because then I will have an idea about the effect of size of the vehicle. Okay, I will have an idea about the effect of the size of the vehicle. Got it? So this is clearance, what you are looking at as a driver. Okay, and from here up to here, you can see the car length is included, right? This is the spacing we use in traffic flow. Okay. So to get the spacing for traffic flow analysis, you cannot just take the clearance between the two vehicles. You have to go from one point up to the same point of the other vehicle. Okay, so for example, I can do this. Front of one vehicle up to the front of the next vehicle. So you can see vehicle length is included, right? I can go from back of one vehicle up to the back of the next vehicle. So again, vehicle length will be included. Okay, so this is the spacing which we are looking at. Clear? Okay, and we already said the relationship between the spacing and density is what? Inversely or directly? Inverse. Okay, so this is what you see here. This is density, this is spacing, and they are inversely proportional. Okay, and what is this? This is a conversion factor because density is vehicles per length. And what is, how much length? Mile. Okay, or kilometers. Okay. But spacing, distance, right? Distance, how much? Miles, kilometers, meters or feet, right? So this is why we need the conversion. Okay, so this is because of the units. Another important factor here is we are discussing macroscopic parameters and microscopic parameters, right? Macro and micro. Okay. Which one is density? Macro, right? And which one is spacing? Micro. Okay. And what was the difference between them?
This is small, this is small.
Then small, then smaller.
Macro for the whole.
For all group of vehicles, right? So density is for the whole group of vehicles. Okay, density is for the whole group of vehicles. Spacing can be for two vehicles, right? But will it become macro? No. Okay, so this is why we have the A here. A means average. So this does not apply to one value. Okay, you took one value of spacing, now you are trying to calculate density. You can do that, obviously. This will give you a value, right? Whatever value you put here, you will get density. Okay, but it will not be realistic because you took only one point and now you're saying the whole group is like this. Okay, the whole flow is like this. Yeah. Okay. And then we have headway. Headway is very similar to spacing. Okay, headway is in terms of time. Headway is in terms of time. Again, the interval between two vehicles. The spacing was interval between two vehicles in terms of distance. Headway is interval between two vehicles in terms of time. So when the first vehicle passes, your headway starts. Next vehicle passes the same point, this is your headway. How much time taken between the first vehicle and second vehicle, this is your headway. Got it? Okay? And again, the length of the vehicle should be included in it. So we are not talking headway between for the clearance, to cover the clearance. Okay? We are talking headway to cover the spacing. Headway to cover the spacing. And the spacing, as I told you, you have to include the length of the vehicle. Okay, so for example, if this is my observation point, okay, and this is the first car. So if I start the headway when the front crosses the point, I will note it till the front of this car crosses this point. Okay? Clear? Sure. So I am trying to record the headway between these two cars with a stopwatch. Okay. So when will I start the watch? When the front of the first car crosses my observation point. And when should I note it down? When the front of the next car crosses my point. Okay. And I can do the same thing by changing the point of observation as well. If I do it for the back, that will start when the back crosses my observation point, and I will end when the back of the second car crosses my observation. Clear?
It's a video lecture.
Huh?
It's a video.
Yes, what?
Video.
It's just a video of this one. Yeah, when I do it on the slideshow, then the whole thing will work. The cars will move and so on. Did you get the idea or not? Yeah. It does something with the recordings. Okay. There. Now, V is called the rate of flow. V is called the rate of flow. And H is called the headway. So what is the relationship between them? Inverse proportion. Okay. And this is very common. You should know. What is this? Yes. Okay. The flow rate is vehicles per hour. And the headway? Not per second, seconds. Headway is seconds, right? Headway is seconds. That's why you need this conversion here. Okay. Just to give you the whole scenario. Why are we doing this? Why are we saying they are inversely proportional? For density, I already gave you the example, right? What about headway? How did they come up with this relationship? Headway is, headway means time interval between two cars, right? So it is time per vehicle, right? It is time per vehicle. And what was the definition of rate of flow? Vehicle per time. Time, right? My time is hour. That's why I'm doing this, right? Okay. But what was the basic definition? Vehicle per time. And what is the definition of headway? Time per vehicle. Okay, so that's why they are inversely proportional. Okay, and what was the meaning of A? Average. Why do we do the average?
Small. There's variation.
Huh? Yes. Which one? Yes. Okay, so because you are using or you are switching between macro and micro, so the average is required. Okay. Yeah. So headway is distance. Sorry, spacing is distance, and headway is time. Distance upon time.
Speed.
Speed. Tell him. Distance upon time is speed. Okay. So that means spacing upon headway is speed. Headway is distance, and spacing is distance, and headway is time. Distance upon time is speed. That means spacing upon headway is speed. Okay. So this is the thing here. This is the conversion factor. We did not use it in the previous example because we kept it feet per second, but normally we don't want it in feet per second. So then we apply the conversion. If it is in feet and seconds, then we want the answer in miles per hour. So this is the conversion for miles per hour. And then this is for kilometers per hour. Same thing. Okay, spacing upon headway. Any problem up till here? Okay, now you came to me right after the last lecture that why do we use microscopic parameters? The first application of microscopic parameters I already showed you here. More importantly here. What am I doing with the spacing? Calculating density. Okay, and I told you calculation of density is not so easy. Okay, so microscopic parameters can help you get macroscopic parameters. So although I need macroscopic, but I can get micro and then convert them to macro. Okay, so this is one of their uses. Okay, density, rate of flow, speed. But what is the condition? Average. Okay, the micro should be the average values. Okay, another thing which I briefly mentioned earlier about these parameters. Some cases in traffic, we want to study a specific type of vehicles. We want to see the effect of a specific type of vehicles or a specific type of drivers. You cannot do it using macroscopic, because macroscopic is one value for the entire group. So I tell you the rate of flow is 2000 vehicles per hour. Okay. But what would it be if all of them were trucks? What would it be if, or what would be the speed if all of them were buses, and so on. Okay. So this type of analysis cannot be done using the macroscopic values. So if you are focusing on a specific type of vehicles or a specific type of drivers, okay, old drivers, young drivers, female, male, whatever. So the macroscopic do not give you enough details to do this type of analysis. Clear? Okay. So one use of microscopic is to calculate other parameters, and the other use is to study specific types of drivers and vehicles. Okay. And they, by the way, when you use any software for traffic flow analysis, they will ask you for microscopic parameters as well. Even if they don't ask you, they are using some default values. So if you go to the default values, your whole analysis, although it may be showing only flow rate and density and macroscopic parameters, but behind them, they are using microscopic. Okay, so you just leave it. Your results can completely change because you did not pay attention to the microscope. Okay, they are default value. They are using it. Default spacing between two cars is this much. Okay, average speed of a car is this much. Average speed of a truck is this much. The acceleration of a car is this much. They use these values. Okay, If you just leave it like this, you can get different results. Okay, very quick, simple problems. We have a congested multi-lane highway. The spacing is 200 feet. The headway is 3.8 seconds. We have to calculate the rate of flow, density, and speed of traffic. Okay. Okay, start with rate of flow. Rate of flow is linked with what? I have two values here, right? Which one will give me rate of flow? 3.8, the headway, right? Okay, so how much? Take it. Okay, and this 200 will give me what? Huh? Yes? Density. How much?
26.5.
Okay, speed? Speed? How do I get speed? Headway? Speed was what? Distance over time, right? So?
200 by 3.8.
How much?
35.8.
Okay, any problem?
Victor,
Yes.
density is per lane.
Per lane. Okay. You were saying why it is per lane.
No, just asking.
Just asking. You were saying something about lanes. No?
Yes,
Why not?
Why per?
Why per lane? Yes, why per lane? Tell me.
Because you count the spacing from one vehicle to another in one lane.
One lane, okay. These parameters, microscopic parameters, spacing and headway are per lane. Okay, so when you calculate from them, it's default per lane. You cannot have headway, one vehicle going here, one vehicle going here. There is no headway between them. Headway can be 0. Headway can be minus between them because they are in different lanes, right? It doesn't make any sense. So when you are taking headway and spacing, they are per lane. So if I write per lane, it's not wrong. Okay, it's not wrong. Okay, and it is per lane. It is per lane. If you don't write it, it can be confusing. Okay, so that's why we write per lane. And the reason is because the values from where you are calculating them are per lane.
So now if you want to count the density, we have to multiply by the number of lanes.
Total, yes. Multiply with the number. What about the speed? Per lane? No? Because I didn't write it. No?
Speed, you took the average. Doesn't matter because it's of the car.
Yeah, because it's not related to numbers. It's not related to number of vehicles. So one lane or second lane or third lane doesn't matter. It's a rate. Okay. What else? Yeah. The first value. What are we calling it? Rate of flow. Okay. Because it is per hour, right? Because it is per hour. But volume is also per hour. Can I call it volume? Why not? Yes, yes. Volume should be actual full hourly value which you have observed in the field. Okay, so far so good. Okay, this one. What do I do? Tell me. They need density and rate of flow. And they have given me headway and speed. What do I do?
Give the space.
Yes.
Give the space and space.
How?
You have the speed.
I have speed.
Yeah. Speed equal the distance by time.
Speed equals what?
Distance over time.
Distance upon time. Okay, so I don't have the distance,
Yeah.
I have the time. Yeah, the speed is given, right? 55. Huh? Okay.
Velocity.
V for velocity. Yes. Thanks. Yeah. How much is that?
$33.7.
33. Hmm?
194.1.
Did you divide by 0.68? Okay. What do I do for rate of flow? It's easy, right? The headway is given. The headway is given. So okay, and what is left? Density. So density is then you have to use the spacing then. You already have the spacing. Okay, any problem? Clear? Okay. What you see here is the basic equation of traffic flow. Okay. One more item here. We have used speed or calculated speed here. We have calculated speed in the previous example as well. This speed is macroscopic, right? Macroscopic, because we are using average headway and average spacing. This is macroscopic. Macroscopic speeds are two types: space mean speed and time mean speed. Which one have we calculated here? Time mean speed or space mean speed? Huh? Why? How do you say that? Because I took the average. Okay. Yeah, it is space mean speed. Okay, it is space mean speed. Why? I don't know. Simple. Okay, this could be because of the average. This is space mean speed. Okay, the main concept is space mean speed should be over the section, over the entire section, and since density is involved here, so we can consider it to be over the entire section. The same speed to be over the entire section. Okay. Okay. So going back to this relationship now, V is rate of flow, S is speed, and D is density. Okay, so rate of flow equals speed into density. This is called as a basic equation of traffic flow. Okay, the most important relationship of traffic flow, and you can see all three macroscopic parameters are there. All three macroscopic parameters are there. Okay, speed, which is speed? Space mean speed. Okay, because it's the equation of traffic flow. Okay, density is vehicles per kilometers or miles, right? So again, over the whole section. Space mean speed over the whole section. Density over the whole section. Okay, what about flow? Is flow over the whole section. How do you measure flow? If I ask you to get me flow, what will you do? Huh? Per time, right? So there is no section here. Okay, there is no section here. Okay, so you have to put a restriction on this equation now. You cannot just use it anywhere you want. Okay, because two parameters are for the whole section, and this one, no. Okay, so what restriction we have to put? Why will these things or when will these things remain over the whole, when will these two things remain constant over the whole section, S and D, when I don't change the section? Okay, these two things remain constant over the whole section when I don't change the section. When I was talking earlier, somebody mentioned we choose a speed on the basis of the intersection as well. So I want to go fast, but there's an intersection. Will my speed change? Yes. Will my velocity change? Yes. So what happened? The section changed. Okay. So these two things remain constant if the section is same. Okay. Intersection is just one example of a change, but there are other things which can change the section. For example, number of lanes. There is no intersection, but we are going from 2 lanes to 3 lanes now. Curves also. Okay. Curve, gradient. Okay. Parking on the side of the road, shoulders, median. All these things are considered changes in road cross section. You have taken highway, right? You have seen the road cross section. Okay. It includes the cross slope, includes radius, sub elevation, number of lanes, width of the road, and so on. So all these things are considered part of road cross section. If you change any of these things, these parameters can change. Maybe in some cases they will not change, but this is a reason that they can change. Okay. So when you are applying this equation and you say S and D will remain same over the whole segment, that means this whole segment is what they call as a uniform section. This whole section is uniform from point A to point Z. Same. And then this equation is valid, it will give you the same flow. So in taking flow for a uniform section, even if you forget about the distance, it doesn't matter. Because the other two things which are depending upon the distance, they will also remain same. You get my point? Okay, so S and D depend upon the distance. Okay, but flow rate has no distance in its calculation. Okay, so how do we make them equal? You make them equal for a uniform section, because for a uniform section, S and D will also don't change. Clear? Okay, so you have to be, the point was in this one and the previous equations we saw, that whenever you are dealing with macroscopic and microscopic, you have to be careful about their consistency. In the previous equations, we took the average to make it consistent with the macro. And here we are putting a restriction for uniformity so that these two can be equal to that one. These two which are depending upon the length can be equal to the third one which does not depend upon the length. So parameters which are in the same equation must be consistent with each other. Okay, they must be conforming to each other. Clear? Any questions? Abdullah Muhammad?
Yes.
Abdullah Wail? Abrar Raid? Ahmad Makki? Ala Adil? Ali Muhammad? Fatma Muhammad? Hassan Isa? Hassan Salah?
Yes.
Hashim Ahmad? Habra Ahmad? Hussain Kambar? Maria Muhammad? Muhammad Khalid? Muhammad Usama? Umayma Yasir? Sayyid Hussain? Salil Fahim? Sayyid Hussain, 2. Sayyid Muhammad? Zainab Abdul Hussain? Zainab Ali? Ziyad Jasim? Thank you.